Hi, welcome one and all. This is Edward Turner, your host for this channel, D-Side Chats. So today we're going to be talking about algorithms. Yes, I know, the boring stuff about data science. But these algorithms are going to directly affect how quick and how fast your data science process is going to run, but then also too how effective, how accurate your process is. And then three, this is one that most people are very happy about, is how then can this quickly get to from your machine out into the world to be used and at the quickest rate possible. So these are the three things we're going to talk about in detail. So first, the data science algorithms, or rather algorithms that you can use. So depending on which language you use, and again, this is more of a conceptual point. I'll have another video about the actual algorithms themselves and the technical point. But essentially, a lot of times when you're developing an algorithm to be used within your data science process, you have to think of what you're aiming for. What are you trying to learn? So think about it from this standpoint. Look at linear regression. Linear regression is trying to learn coefficients across all of the columns for each row. Try to learn those coefficients that actually can compare across all the rows for that column. Now, how can it do that? Well, there's a few ways of doing that. But one way that's surefire to be used is thinking about this as a math problem, creating what's called a matrix and a vector, and then applying a vector operation onto that matrix to get your predictions, which is your y variable. So that ax equals y, maybe if you took linear algebra before, this would be familiar to you. If you took statistics, you can kind of see this. But for those who haven't, this is the quickest way to solving a problem. Now, there's multiple ways to solve the ax equals b problem or ax equals y problem. And a lot of these problems can be divided up into a few different ways. I'm not going to go into those deep, heavy concepts, but there's multiple different ways of doing this. I'm going to name a few names so that you can do some research later. One way that is the guaranteed, surefire way of doing this from a linear regression standpoint is going to be the least squares method or approach, ordinary least squares, OLS. Remember that. So that's one way of doing that. And that's an algorithmic approach that has a solution, a unique solution. Another approach is, which are solutions to the same OLS algorithm, which is an actual computer algorithm that goes through, looks at the difference of squares, add them all together, and tries to find the coefficient, which is x, and try to match everything up appropriately. And x is what you're looking for. And so typically, that's what you would do in that type scenario using an algorithm, but you can also do this using matrix operations. I'm going to list a few names. Don't worry about this too much, but these names are going to be highly important for everything in data science. So I'm going to suggest that you remember these because this is going to relate back to other data science concepts. I'm going to list the names. So you're going to have the eigenvalue decomposition, which basically means you're taking a matrix and you're breaking it up into two separate parts. One part is a matrix that's unique, and another part is a matrix that is scalar, meaning that all the entries in the matrix are zero outside what's along the diagonal. If this is your first time, by the way, hearing any of these concepts from a math perspective, stay tuned. Complete watching this video, ask questions, but stay tuned. I will provide a video that dives deeper into each of these. And if you're too impatient, just go and just Google search eigenvalue decomposition. Just put eigen, E-I-G-E-N, and then decomposition. And so eigenvalue decomposition, look for that. And then you have another type of decomposition called a singular value decomposition, or SVD. Now, if you have looked at sklearn and looked at the different packages and different types of methods involved, you may have seen something called the Truncated Svd Method. This method is actually very useful for latent dimensionality reduction and analysis. You can actually learn the latent dimension, so to speak, of a very complicated matrix, which normally ends up being some type of term frequency matrix that you develop throughout your data science process from an NLP type algorithm. And so this is actually very useful overall for that type process. But you can use this as well on top of your matrix. And these are actually become solutions. You can actually get to the same or close to the same solution as the ordinary least squares equation, or OLS, as you can with these other two, eigenvalue decomposition and SVD. So these are two ways of solving that problem, both of algorithmically kind of cubic. And so they're they take a lot of time to solve. You get some very nice things about these matrices, and you can learn a lot for sure. But it's very complicated to solve it. All depending on what type of matrix you work with first. You know, this is all again based off of your initial A matrix, your data matrix, and it's going to be based off of that. But they're all very complicated. And so if you were to use this technique for everything, you would run out of time. You see, this is what I mean by the algorithm that you choose is going to lead to your solution, and how quickly you can produce that solution. Now we're going to talk a little bit more technical at the deeper down algorithmic level, and this is going to be based on how you write the code. So there's the algorithm process, which the direct machine learning algorithm that you use, or the direct algorithm you use to solve a machine learning problem, can be the key factor for you not being able to get to where you want to be at the time you want to be. But also now, you're going to have to program in such a way that you're not going to cost yourself time. And so if you listen to one of my videos before, I talk about different languages you can use, Python, R, Scala, and they all have their different benefits and pros, but they also have different cons. And one of the cons about Python specifically, which is the main language for data science, it can be very, very slow. And this is 100% depending on how you write your code. Now, you can do things in a way that is so-called vectorized, which basically means you can apply operations across all the rows at lightning speed using some type of instructions are on the machine that Python is able to utilize. And those are things that you can do. However, if you do this in an improper way, then you do it row by row. And row by row in Python is the slowest thing you can do. I've actually seen this in practice. So this is not just something that beginners make mistakes. This is also what some professionals do, and that's because they lack the overall knowledge of Python. And this is where you get a machine learning engineer to come into play, which is what I am as well. First data science, now machine learning engineer. But you know, this is where really understanding Python and how to create solutions comes into play. Python interprets things one at a time. So if you don't vectorize something and allow Python to interpret it once, it's going to interpret it every time you try to reference it. So if you have 10 rows and you didn't vectorize the operations, instead of it trying to interpret one thing for once, it interprets 10 things each time. And that takes up a lot of time. And so how you use your code and how you develop your code is going to lead into this machine learning algorithm. Now you can use things like C, C++, and you may have heard me say this in my other video too. But those by themselves, while an excellent solution to some complicated problems, is not necessarily the easiest thing to do. And if you don't have the skill set to work with C and C++, you won't be able to use those optimizations, and you pretty much come back to plan A or point A. And so I suggest looking at your algorithm, understanding what it's really doing, and then also at the same time building things in such a way that they're vectorized. And there's a few things. I'm going to throw off some names, so don't be afraid if you haven't heard of these before. But pandas and NumPy, you can do things row by row, but you also do things vectorized. So if you see something you can do vectorized, use it. And then there's something else called Numba. Numba is just-in-time compilation. There's a few other just-in-time compilation packages available through Python, so it's not the only one. But Numba is extremely useful because you can actually just call a decorator, basically a function that wraps around another function, or there's tutorials for that, and I'll eventually create a video for that too. But essentially, Numba, what it does is it takes that for loop that you were maybe using before that was accessing one row at a time, understands that you really mean that you want to vectorize it, and does it for you. So it becomes a point where it does a lot of the work for you. I have seen algorithms, I have produced algorithms that have seen a dramatic boost of performance. I'm talking about a 60 to 100 times performance boost just by using Numba in places that matter. And this is even where you're using NumPy. If you're using NumPy for vectorizations, Numba will still make it about 33% faster. So use Numba, learn it. First, learn how to vectorize everything. Learn that first. That's the biggest bang for your buck. But learn Numba too. And then once you get more comfortable, come back to me. There's a few other things you can do. You can use parallelization using Dask and PySpark. They can wrap around with Numba. You'll see some huge performance boost. And then you can even use something called Apache Arrow, which is another performance boost for Spark. And so come back to me. If you're interested, again, subscribe to the video, subscribe to the channel, like the video, make a few comments in the comment section. Let me know what you think, and then I'll go and produce a video for that. Now, last but not least, is how can you get it to the user? Now, this is all dependent on how you want it to be delivered. So this is more of a trick. This is a trickier solution. This is going to be a trickier type of problem to solve. If you're doing streaming, if you're streaming information and you want the stream come in and then go back out to the user, this right here requires a big data framework like Apache Spark or like Apache Kafka or like Apache Flink. And those are Apache products that handles big data operations that can handle streaming. If you're looking from a standpoint of batches, meaning that you make a prediction at one time and you kind of keep this prediction static and then you just reference those every time, then that's a little bit simpler. You take the file, save it somewhere. You make if you're doing this on a web application, you make a web application to reference that file. There's ways to do this that can improve on performance, so I do suggest that you do some additional research and see what you actually need. But you can do this in a way that reads those predictions and pushes it back out through a web application. I've done this in the past. If you're curious to learn more, let me know. I will make a video about that as well. There's a lot of things I can really teach you guys about. Now, the other video in particular, or the other video that will be useful for you to know, especially from a web application point of view, is what type of web framework you want to use. Do you want to use something that is synchronous, meaning that things happen one after the other? Or you want something that's asynchronous, which means multiple things can run at the same time? That will be a topic in another video, but bear in mind, please be patient. There's a lot of things to cover, and that's why you're here. You're here to learn. And I want to be sure that you learn and so that you can join me in this field and maybe we can work together. Who knows? But this is kind of like how you can make sure that your algorithms, your data science algorithms, can get back to the real world. You either handle a streaming service, which is very complicated, or you do batch operations and have a web application, which is not as complicated, but still requires a lot of effort. And then you have to know, really, how these predictions are going to be used. Because you can do anything you want with streaming information or sending batch information to a web app, okay. But how your prediction is going to be used, is it going to be used to provide a recommendation for a user for a product, or is it going to be used for price recommendation? Or is it going to be used to help predict the value of stocks, or is it going to be even used to help predict maybe the weather for tomorrow? Who knows? But you have to realize what your prediction is going to be used for, and then how to monetize that. And that's going to be an ongoing topic that you probably hear me talk about in other videos. So anyway, I hope that you learned something. I hope that you can share this with your friends, anything that you learned that can be helpful and useful in your journeys to get into data science. Again, if you like the video, subscribe to the channel, and then like the video and comment. I want to see what your opinion is. All right. Ciao.